Welcome to next session. Today, as discussed, we will, as told in the previous lecture, we will try to discuss on shift registers and few simple. So, since mid semester is scheduled in next week, I would like to conclude to a large extent in today's session that shift registers I will discuss. For the mid semester, sequential circuit videos which I have already put, pre-recorded videos, all lectures, operational amplifier videos, all lectures, actual videos right from the beginning which I have told, which I have put at the time of each lecture, that is fundamentals of Arduino, and the remaining lectures of counters and shift registers, all lectures will be there. Diode and transistor will not be there as a part of syllabus, so only on diode and transistors these are given to you for a better understanding. So nothing will be there from diode and transistors in the mid semester examination. So mid semester will consist of first two modules, then fundamentals of third module, that is the microcontroller in Arduino as required for engineering background. We have discussed fundamentals of microcontroller. So based on that, there will be some questions. So all videos are needed to watch very appropriately, and I am sure that if you watch all videos appropriately, everything would be very much easily answerable in the mid-semester examination. Today we shall finish shift registers and combinational circuits. Means now the digital electronics, or in general digital logic, is there coming at high school. So simple AND gate, OR gate, XOR gate and all that discussion is expected to be finished. So for 12th it is already over. For vocational it is much more than over, but for everybody it is simple. So only some detailed, or what we can say, some latter parts of combinational circuit, that is adder, subtractor, multiplexer and decoder, are there for our syllabus, that we shall finish. So that is very simple, and there is no need for any kind of spending detailed time. As I had see now, it's a Google age today. So there is no point in repeating something which students can on their own obtain. Rather, the classroom discussion should be focused in order to ensure that the difficult concepts are understood by the students in a more better manner. So shift register. So what is a register? In the microprocessor logic you have seen a register. In earlier sequential circuit lecture you have seen a flip-flop, JK is there, RS is there, but from as regards to register is concerned, shift register is just like a scratch pad. Scratch pad, or in general shift is different aspect, register is like a scratch pad. Register is like a scratch pad where you can write anything what you want, you can wipe it out. Again you can read, means it's a read-write table, or register is a scratch pad, memory location time. So D flip-flop we have seen, D, Q and Q bar. The Q bar normally is not required in registers, and it is having a clock, active low clock. So what is the truth table of the flip-flop was explained in the earlier video? Clock and Q. This is a simple truth table. Clock 0, clock going up, clock 0, clock 1 or clock going up. Normally these are active low. Q remains last state. Flip-flop maintains last state. And when clock is going down, it is D. So very simple. Whatever you apply, inputs are D and clock, output is Q. Q bar is not auxiliary, not required to a large extent unless we are having some specific applications. So what happens? It is a clock D flip-flop. It is also called as D latch. It is also called as D latch. And it's a clocked. So when clock goes down, that time for a small period, it is infinitesimally small, it is a few microseconds. Whenever clock goes down, in the immediately small, see, this is a broad discussion I am telling for understanding. Whenever clock goes down, immediately at the falling edge of the clock, we get a 10 nanosecond period in which the enable input of internal D flip-flop becomes 1. So whatever is put on D at the time of falling edge of the clock appears on Q. And once the clock falling edge is over, whatever is put at D is not affecting output Q. मराठीत सांगतो. क्लॉक इनपुटची फॉलिंग एजच्या वेळेला जी डी ची व्हॅल्यू आहे ती व्हॅल्यू क्यू ला ट्रान्सफर होते आणि एकदा ती एज निघून गेली डी मध्ये काही जरी बदल केले तरी क्यू बदलत नाही. आय विल एक्सप्लेन इट युजिंग ए ग्राफ, युजिंग ए डायग्राम. So D is an input. You can give any input. Say input is like this: slow, low, high. Like this. Clock is regularly featuring So initial D we don't know, but when this, I am drawing output at the top. So this is D, this is CLK, and here I am plotting Q. Logic is very simple. At the time of falling edge, here it is just as if shutter opens. In photograph, what is seen? Whatever is in the, now the concept of shutter and all that is history. You are having a snapshot. So when the shutter opens, that time only the things beyond the lens of the camera are recorded inside the camera. So whatever is value at this falling edge, what is D? This one. So D becomes 1. Previously it may be 1, it may be 0. It's immaterial. It can be 1, it can be 0. We can't say. Now, nothing is going to happen. Here D has changed. Here, let us say that input D has changed here. This change will not affect at all. It would be observed at this age again. What is D at this age? 0. So, at this time of this age, when the clock goes down, that time D is transferred on Q. Now, no change. So this D has become 1, it has become 0, but what is D at clock going down? It is again 0. So it will continue to be 0. Here also it will continue to be 0. And when at the time of next pulse, at the time of this pulse, it is 1, so it is 1. So what is a D flip-flop which is required in shift registers? It is very simple. Even if you don't know anything else, what I am telling right now is much more than sufficient. The D is input, Q is output, and clock is enable input. Whatever is the state of D, whatever is the input level of D at the time of falling edge of the clock is transferred to Q, and at all other times Q continues to maintain last state. Changes in the D are not at all transferred to Q. These are simply ignored. क्लॉकच्या फॉलिंग एजच्या वेळेला जे डी या इनपुटचं स्टेट असतं हाय किंवा लो ते क्यूला ट्रान्सफर होतं, आणि इतर सर्व वेळी जेव्हा क्लॉकची फॉलिंग एज नसते त्यावेळी क्यू जुनी स्टेट मेंटेन करतो. सो इट इज पॉसिबल फॉर अस बाय गिविंग ए active low pulse falling edge, we can write whatever we want in the latch. So it is called a deep loop, is also called as latch. Whatever you put and give clock is stored in the flip flop. What is the meaning of storing? What is concept of storing? The thing available now and may be required later, and that time it's not available. So whatever is now available is transferred and stored, because that may go in between, but that gets stored once a clock falling edge comes, and it is stored till the next falling edge of the clock. So the status, if ever output Q of D flip flop is to change, it will change only at the time of falling edge. So whatever is value of D at the time of falling edge is transferred to Q. So this is concept of shift register. What is a register? Simply we are having, let us say it can be 4, it can be 8 bit, 16 bit, but it can be 2 bit also, but 2 is too low. So normally we consider a 4 bit register. Normally we consider a 4 bit register. So a 4 bit register means 4 D flip flops. Flip-flops. Clock of all flip-flops is made common. In most of the circuits you find that when the digital circuits were introduced a few decades back, that time the concept of asynchronous circuits was there. That is, different parts of the circuit were driven by different clock inputs, but nowadays you will find that almost all circuits are synchronous circuits, because bulkier is now not an issue, because you are having a very advanced VLSI technology where you can construct a very complex circuit in Q. Clock of all is made common. Clock of all flip-flops is made common, and that serves as a overall clock. These 4 are the outputs. These are Q0. I have just joined deliberately in this side. You can join reverse side also. Only thing is that the connection diagram would be requiring some kind of complex way of showing. So even though in fact for shift register there is nothing like LSB, MSB, but if it is requiring some kind of arithmetic operation, then this will be meaningful. So Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3, or you can give A, B, C, D also. There are many conventions. These are the outputs. And what are the inputs? Now this is the shift register. It is called a shift register. Why it is called a shift register? Again, it's very simple. In fact, maybe 3 decades back, understanding of shift register was itself a very difficult concept, and the things were not that much advanced, so this used to be very important part of the syllabus at the third year. Now it is at the first year. Then I will give inputs where I should show inputs. I will show inputs here and I will map that around. D0, D1, D2, D3. D0, D3. I will draw the entire diagram. First of all, I will make it some more simple. If I do like this, what will happen? Most simple. It's actually not a question, but just I am asking. So it is just 4 D flip-flops taken together. When I put clock, D0, D1, D2, D3 will be transferred to Q0, Q1, Q2, Q3. D0, D1, D2, D3 will be transferred to Q0, Q1, Q2, Q3. This is, we can put some value in the register. Now I will make small change. What change I will do? So what will happen now? It's a very interesting situation that now inputs to the flip-flop, D flip-flops are coming from previous flip-flops output. Input to a flip-flop is coming from previous flip-flops output. In such situation, what is going to happen? In such situation, whenever clock comes, what will be transferred at Q0? S in. This is called as serial input mode. Whenever clock is available, what is at the time of falling edge of the clock, this flip-flop is having S in at its D. This flip-flop is having Q0 at its D. This flip-flop is having Q1 at its D. And this flip-flop is having Q2 at its D. So whenever clock comes, Serial input would be transferred to Q0, old Q0 would be transferred to Q1, old Q2 will be transferred to Q2, Q3, so old Q1 will be transferred to Q2, old Q2 will be transferred to Q3. So suppose if initially Q3, Q1, Q2, Q0 are 1, 0, 1, 1, and if I apply S in equal to 0, what would be next state of Q3, Q2, Q1, Q0? What will be next state of Q3, Q2, Q1, Q0? Listen very carefully. If Sin is 0, what is this D? It is Sn. When clock comes, whatever is at Sin will transfer to Q0. Sin is 0. So Q0 will be transferred at 0. What is for this one? What is its D? Old Q0. So this one will be transferred here. This one will be transferred here. This will be transferred here. This is shift. So I am shifting this on this side. It is going to shift left. I have got old number. I am inserting a new bit and transferring all bits on the left hand side. This is input. Serial input is connected to input D input of first flip flop or least significant flip flop, and its outputs are connected to further. Now I want both things. Previously what I said, when inputs are available outside, in previous case I have shown all D inputs are available outside. All D inputs are available outside. So when all D inputs are available outside, what is going to happen? Whenever clock comes, D0, D1, D2, D3 gets transferred to Q0, Q1, Q2, Q3. That was one case, and now I have shown you a separate case. Now both of these cases can be combined by a simple additional circuitry that will be covered in next part as multiplexer, but right now I will show it very easily. So here what I will do is this is an OR gate. This is an OR gate. I will show. So I will draw the detailed diagram here and I will repeat it elsewhere. This is the most simple circuit. A, S, B and Y. A, S, B and Y. So what will happen? What is going to happen if S is 0 and if S is 1? What will happen if S is 0 and if S is 1? So just I will a small change, not needed, but normally it is a convention, so I am drawing it. So can you write the truth table between S and Y? When S is 0, when S is 1, what will happen? I will explain. In fact, this is called as a multiplexer that is required in this discussion. So those who want to try on their own can put a pause button, think on their own, come up with the answer. If it is fine, then if they are able to find it, then they can verify, and if they are not able to find it, they can watch. So those who want to try can pause, and immediately after either they are able to do or not able to do, they should resume the video. So it's very simple. If S is equal to 0, if S is equal to 0, this will be 0, this will be 0. When S is 0, this is 0. When S is 0, this is 1. When this is 1, this is A, this is A. It's very simple. Right? See now, this multiplexer I will explain again in the next part, but it's too simple. Again, as I already say that I already said that 3 decades back it was a very important concept which should be taught in detail. Now it is too simple. When S is 0, this is 0, this is 1. When S is 0, irrespective of B, this is 0. This is 1. As this is 0, I need not watch at B, this is 0. When this is 1, this is A, 1 into A is A. 1 into A is A. So input is 0, input is A, Y output is A. When S is 0, output is A, means whatever is at input A comes on output Y. When S is 1, what is going to happen? This is 1. When this is 1, this is B. When this is 1, this is 0. So this is 0. So 0 and B, Y is B. Y is B. Y is B. Right? So this is, means you can either choose, so this big block is drawn, this big block, it can be repeated or it can be shown by a symbol like this. A, B and S is shown here, this is Y. So this need not be drawn each time. So when S is 0, Y is A. When S is B, when S is 0, Y is A. When S is 1, Y is B. So now what we do is, I draw this small diagram because at all 4 places this multiplexer is required. I will draw it, I will explain it in detail. Now for each of these, this entire block is put. Now clock I am not showing, clock of all is made common. Clock of all is made common. So in normal sequential circuits now, clock need not be shown, clock is assumed common for all. So now this is coming as Q0, Q1, Q2, Q3. Now it is very simple. Only thing is that since there are 4 units, its circuit is bulky for drawing and nothing not for understanding. So what is this shift resistance having? 4 parallel in. It's a 4-bit shift resistor. It's a 4-bit shift resistor. It is having 4 parallel inputs: D0, D1, D2, D3. It is having 4 outputs: Q0, Q1, Q2, Q3. It is having one serial input, S in, and it is having a mode called as serial oblique parallel, S oblique P bar. It is having a mode called as S oblique P bar. When it is S oblique P bar, means when the pin is 0, when S oblique P bar is 0, what will happen? When S oblique P bar is equal to 0, this will be select inputs of all these multiplexers. When this circuit will repeat this circuit, that is the circuit consisting of 2 NAND gates, two AND gates, one NOT gate and one OR gate. This is called as 2S1 multiplexer. When S is 1, Y, when S is 0, Y is A, when S is 1, Y is B. It repeats here. So it repeats for 4 times. So when this is 0, whatever is at edge of, so now this is D. In previous case I have shown you separately what should be if D is, I was giving some fixed thing at D. Now what happens? To D input of each flip-flop, output is connected from a unit called as 2S1 multiplexer. So either if this S of all is made common, so if this S is 0, edge of all these 4 input, this is 2S1 multiplexer, 2S1, 2S1, 2S1. So all A's will come on respective D's. So when S oblique P bar is 0, when S oblique P bar is 0, this D will be D0, this D will be, when S oblique P bar is 0, this D will be this A is D0. So when S oblique P bar, when S oblique P bar is 0, this D will be D0, this D will be D1, this D will be D2, and this D will be D3. And when clock comes, when clock of all is made common, I am not showing it separately just to avoid bulkier connections. Clock of all is made common and it is available at the input. So a separate input is there called as CLK. Or if you want, I can show it. Otherwise, somebody will say, no, sir, clock is not shown how the circuit will work. So if S oblique P bar is 0, at the time of falling edge, if S oblique P bar is 0, at the time of falling edge of the clock pulse, D0, D1, D2, D3 are transferred to Q0, Q1, Q2, Q3. So you can parallelly load the shift resistor by selecting the parallel mode. S oblique P bar 0 means it is parallel mode. And when S oblique P bar is 1, what will happen? When S oblique P bar is 1, what is going to happen? When S oblique P bar is 1, the pin S oblique P bar is connected commonly to pins S of these select blocks. So when S oblique P bar is 1, this Y will be this B. What is this? S in. This Y will be this B. What is this? Q0. So when S oblique P bar is 1, inputs to these 4 flip-flops would be S in, Q0, Q1 and Q2. So when S oblique P bar is 1, it is called as serial mode. In serial mode, what will happen? When clock comes, this Q0 will be, this S in will be transferred to Q0. This Q0 will transfer to Q1. So S in will come here, old Q0 will come here, old Q1 is here, that will come here, old Q2 will come here. So I will show it again by taking an example. So if Q3, Q2, Q1, Q0 are 1, 1, 0, 1 and you select S oblique P bar as 1 and S in as 1, what will happen? What will come at Q0? S in will come at Q0. What will come at Q1? Old Q0. So this will be transferred. What will come at Q2? What will come at Q3? This will go out. So this is left shift. So it operates in left shift mode. So Q0 goes to Q1, Q1 goes to Q2, Q2 goes to Q3. So this is transferred, Q3 is flushed out and you add new input from S in. So Q0, Q1, Q2, Q3, you force them ahead and add new input. In parallel mode, you put D0, D1, D2, D3, give clock, transfer all 4 parallelly. Now we are coming to end of this session of shift resistors by asking a very interesting question. I will ask the question. Those who want to try can put a pause. can try on their own. If they are able to answer, it's okay. Otherwise, they can verify. Otherwise, they can watch. So after I finish this, there will be one more lecture which I will be putting by tomorrow morning. Tomorrow is a holiday, so you can watch it at any time. And after that, that will be the end of the lecture sessions before mid-semester examination. That last session would be adder, subtractor, multiplexer and decoder. It is very simple, and that I would be able to finish it in 50-55 minutes. So that would be end of the pre-mid-sem lecture. So right now, for shift register, I will ask you an interesting question. So what shift register does? Shift register can parallelly load the data. You can put the data, that data is loaded parallelly at the output. So data is put, all 4 bits are put on D's, that those appears on Q's. Or you can put the data one by one. So old data you can shift, new data you can add. From where you can add? So old Q0 becomes new Q1, old Q1 becomes new Q2, old Q2 becomes new Q3, and old Q3 goes out. And Sin becomes new Q0. So what is in serial mode? What is Q0? In serial mode, Q0 is Sin. What is Q1? Q1 is old Q0. What is Q2? Q2 is old Q1. What is Q3? Q3 is old Q2, and old Q3 is left out. Now somebody will say, sir, why it is like this? Can I do in reverse manner? Means shifting should be reverse, right shift. Right shift. Let us say what I should be able to do? I should be able to add data from this side. New data I should be able to add from this side. So I should be able to add something new here. This Q3 should be transferred here. This Q2 should be transferred here. This Q1 should be transferred here. And this should move out. And I should be able to add a new thing. If I can put 0 input, I will put in here. So this is called as right shift. This is called as right shift. Left or right depends upon how you look at it. There is no universal convention for that. So the question is, without making any changes in the internal hardware, by making some external connections, will it be possible for you to achieve the loading of shift register in a reverse manner, that is right shift? So we have seen 2 modes of operations. Number 1, parallel mode. In parallel mode, D0, D1, D2, D3 appears on Q0, Q1, Q2, Q3. There is one more mode called as serial mode, in which there is another input pin provided, that is Sin, and whatever is available on Sin comes at Q0, Q0 goes to Q1, Q1 goes to Q2, Q2 goes to Q3. But I want reverse operation, so just you can, those who want to try can put a pause, try something, and after some time they can resume. Okay. So what we have, I want Q3 to come at Q2, Q2 to come at Q1, Q1 to come at Q0, and new thing I should be able to add at Q3. It is very simple. So what I will do, I will select parallel mode of operation. So I will select S/P bar equal to 0. I will select S/P bar equal to 0. What I want, when S/P bar equal to 0, what would be new Q0? What will be new Q0? D0 will be Q0, D1 will be Q1, D2 will be Q2, D3 will be Q3. What you want? You want shifting in this way. So Q1 should be transferred to Q0. So what will you do? What will you do is just have a small connection from Q1 or since it is too bulkier, I am using a blue connection, and I am just showing like this. So this time not using the convention of skipping the like this, I am not doing, because it will be too long. So now what happens? And new input, I can, this I will get input pin. So S of equal 0, Q3, Q2, Q1, Q0. If this is 1, 0, 1, 1, then what will happen? When clock comes, it is parallel mode. It is parallel mode. When it is parallel mode, what will happen? When clock comes, when it is S over P bar is 0, whatever A is appearing at D. This A appears at this D. This A appears at this D. This A appears at this D. When S over P bar is 0, it happens like this. So what is at this D? This D3 is there. What is at this D is this D2. But what is this D2? Is old Q3. What is this D? What is at this D? This D1. What is this D1? Old Q2. What is at this D? This D is equal to Q1. So what will happen? What will come at Q3? What will come at Q3? This is input pin. So when you were transferring from left side, you using S in input. But for reverse transfer, this input is ignored. This input is not to be taken. You add new input here. If this new input is 0, then Q3 will become 0. What will be Q2? Q2 will be D2. What is D2? D2 is old Q3. So this Q3 would be transferred. This Q3, I will draw it with another color pen. So this new input is 0. This Q3 would be transferred to Q2. What will be Q1? Q1 will be D1. What is D1? D1 is old Q2. So old Q2 will be transferred as 0. What is Q0? Q0 is D0. Means when clock comes, D0 is supposed to get transferred to Q0. What is D0? D0 is old Q1. So old Q1 is 1. So what I am doing? This I am shifting. This I am shifting. So this goes out, is not used. This one gets transferred here. This 0 gets transferred here. This one gets transferred here, and new input is added here. So I can operate the shift register. I can operate the shift register in parallel mode, where I can use 4 inputs directly. So these interconnections are made. So this D0, D1, D2 are not made available for the user, because they are taken directly from Q3, Q2, Q1. So these are internally connected. This D3 is available as input. For serial input means now in normal serial mode it is Q0 to Q1, Q1 to Q2, Q2 to Q3, and S into be new Q0. In normal parallel mode, D0, D1, D2, D3 directly transferred to Q0, Q1, Q2, Q3. And just by making some kind of jugglery, some arrangement, I can have a reverse shift. So by making some connections between input and output, I can treat this D3 as new input. So this new input I can insert from Q3 in. Q3 goes to Q2, Q2 goes to Q1, Q1 goes to Q0, Q0 goes out. So I can have all possible modes of operations. Number 1, parallel. Number 2, conventional serial, in which shifting is done from Q0 to Q3 side. And by using parallel mode and having some interconnections, I can have reverse shifting mode. So I think whatever is as we can have other possibilities, how to reset and something like that, how to cascade shift registers. But I think now this is not beyond the scope of this first year compressed syllabus, especially if it is generic for all branches. Therefore, as regards to shift register, I would like to end here. Now only some simple points. In fact, actually what I say that tomorrow I will be uploading that lecture, but I give you homework that you should go through adder, subtractor, multiplexer and demultiplexer or decoder. The better word is decoder. Adder, subtractor, multiplexer and decoder. You try to read on your own from now. There should not be questions, sir. What are reference books from where I should read? You are the privileged students of a Google University, so you can watch it or refer it anywhere, so that tomorrow when you actually watch my lecture, you will be in a better condition. I think for today it is enough. We stop here. Thank you.